tan thetas plus 1. Okay? And from making those two tan oh my gosh. 2 tan thetas plus 1. No, it's not the gap. Yes, there you go. So now you're in this form where you actually can multiply, right? You multiply by foiling. So when I foil, I'm going to tan times tan gives me tan squared theta. Tan theta times 1 plus 1 times tan theta is going to give me 2 tan theta. Your two insides are going to be combined. If I have 1 tan and 1 tan, that makes what? 2 tan, right? Correct? We're in agreement? Okay? And then if I have 1 times 1, that's simply 1. So this is what I end up with after I FOIL and combine like terms. Are we all on the same boat still? Okay. Where's the next part of my notes? Okay. So after you do this, the next thing you should check for is, next thing you need to note is that just because it's written in this order, because it's addition, that means things are movable. Yes, sir. It's generally seniors. Mm-hmm. This is senior level course. Mm-hmm. Okay, so because it's addition, it's movable. So even though if I'm looking right here, I'm like, ooh, I don't see anything. I don't see how that could possibly be anything. I don't see how that could be an identity. What I can do is I can move tan squared, right? Plus 1 plus 2 tan theta. Is this an identity?
Yes.
It is. It's one of our Pythagorean identities, right? Mm-hmm. This is a Pythagorean identity. And what do we know tan squared theta plus 1 is? So now I have secant squared theta plus 2 tan theta. Oh, and now I have Mr. Acosta at the door. All right, here we go. So at this point, this is the furthest we can go. Because we don't know how to use 2 tan theta, and we don't, this is where we would stop at. So now we have something we can deal with. The reason why you just break down, the reason why I chose this problem is because I wanted to show you how you can move things around. Okay, note, if it doesn't look like a identity to you, and it's addition and subtraction, move it. Shift it. Make it look like an identity for you. Okay? The only thing that you need to make sure is that if the number is positive, keep it positive. If the number is being subtracted, which means it's negative, keep it negative. Okay? Move the signs with you, and you can work the problem and identify identities. I noticed that was a big struggle yesterday. Good? All right. Are we comfortable with foiling? Are we understanding the fact that it's movable with addition and subtraction?
So is that an answer?
Yes, that's where we're going to stop at.
Oh, okay.
I don't feel like doing the, recording. It's not that I don't feel like it. We don't have time. Okay, next. The next thing that we need to go over is the difference of squares rule. Difference of squares you learn in Algebra 1, Geometry, and Algebra 2. It's when you have a squared minus b squared equals a minus b times a plus b. Okay? So what that's saying is that your first term and each binomial is the same, and your second term and each binomial is the same. The only difference is their operations. Okay? One would be addition and one would be subtraction. It doesn't matter if this order is switched, they are equivalent statements. Alright? So if you know this identity, instead of having to FOIL this out, you can simply say, okay, well, my A obviously has to be secant theta, and my B obviously is tan theta. So since I know my A and my B, all I have to do is do what to take them out of this form? Plug them in. Secant squared theta minus tan squared theta. Oh my, that looks like an identity. Is it an identity?
1.
And what does it equal?
1.
1. And all we did was use our algebra skills to get here.
That was like a lot. Holy crap.
So you notice, all I did was say, okay, this term and this term are the same. This term and this term are the same. The only thing is I have an addition and I have a subtraction.
If they were both addition, you would have to pull them.
Mm-hmm. If they were both addition or both subtraction, you would have to flip.
Which one is that, Joe? What? Which of?
Identity? Yeah. It should be 1 plus tan squared equals secant squared.
Oh, right.
You, no crackers, because you keep leaving that trash on my floor.
No,
Yes, you did. If you don't put those Lance crackers back in that backpack, every day this week they've been on my floor. Put them in the backpack. You can even ask Bree. She came in here. She said, "Was Javon eating crackers in here?" I was like, "Exactly. I'm glad you noticed too." Yes. You're the only person that sits here and eats Lance crackers in the middle class. Okay. So was that hard? No, it wasn't. And all we did was use something that we knew from algebra and incorporate it into trigonometry. And I was at fault because I would assume you would notice those. I assumed that you would notice those similarities.
They're gonna be -1.
Huh? We're not. It's factoring. We're not solving. We're factoring.
That's what the quiz over. But it's the answer, though, right? Because this has a negative on all the notes, this is
I know.
positive 1.
No, that means this would have to be a negative sign squared, and it's not. All right. Notice this says factor. Okay, we're not wanting to simplify, we're wanting to factor. The reason why we're going over the factoring rules is for that when y'all are in fraction form, you guys have been trying to just eliminate things just because it's there. So if I wrote 2 plus 3 over 2 on the board, what would you tell me the first thing for me to do? You would tell me to cancel out the 2, and that is not the case, because if I cancel out the 2, that means that this problem is 3. And no, 2 plus 3 divided by 2 is
2.5.
Thank you. Not true is true. You cannot cancel out a term when it's being added or subtracted. Okay? You cannot do this. You only can cancel out a term when it's being multiplied. So if I had 2 plus 4 over 2, I could factor out the 2, which, we wouldn't really do it, but now could I cancel out that 2?
Yeah.
Yes. And what's the answer? 3. And if I hadn't canceled out that 2, it would still be 3, right? Because 2 plus 4 is 6, and 6 divided by 2 is 3. This is a true statement. This, however, it's not. It's never have been, never will be. So stop just trying to eliminate things. So that's why we're going over factoring, so that you can learn to create forms of elimination. Okay? So what we're simulating is that these are the numerators of a fraction. And this is a numerator of a fraction, and we have something in the denominator that can cancel out with it, but is not in this form. We have to get it to that form. Okay? Sine squared theta minus cosine squared. Notice how I have squared, minus, and squared. So this comes back to being a squared minus b squared, right? And in this problem, my a is sine and my b is cosine. Because I identify my a and my b, and it's in this form, all I have to do is plug them in, right? I just got to plug them in. So I'm going to plug them in. And I get, what am I going to get when I plug them in?
Sine theta minus cosine theta.
There you go. And then what else?
Yeah, negative positive.
There you go. We have 5 minutes on our quiz. So, sorry. Okay, we have 5 minutes to our quiz. All right, so now I'm in this form, and now that it's been factored, if I had something in the denominator that one of these could eliminate with now, could I eliminate it?
Yeah.
Yes, because I took it from being a strictly subtraction problem to being multiplying. And because I'm in multiplication, remember, that's when we can eliminate. Okay? We only can eliminate when something is being multiplied. Got it? All right. On 4, it's factored. We're just practicing factoring. We're not seeking an answer. Okay. All right. So we have cosine squared theta minus 2 cosine theta plus 1. This is factoring by grouping. Okay? Well, actually, it's not factoring by grouping. It's factoring by, what do you call it? It's like CAB. Do y'all remember CAB from Algebra 2?
C and then the
C
line
times
and
A
B.
equals B.
All right. So CAB is, you hate CAB? All right. CAB is C times A and B, correct? So that says if I take 1 and times it to cosine squared theta, I'm going to get cosine squared theta. We all agree? And then I want to know what times what gives me cosine squared theta, but adds to give me 2 cosine theta.
That's cosine plus cosine. It's just 2 cosines.
And what kind of cosines though?
Negative.
They would both have to be,
Negative.
Oh, yeah, negative.
they would both have to be negative cosine. Negative times a negative is a
Positive.
positive, and negative cosine theta plus negative cosine theta is negative 2 cosine theta. So that means that my factors are x minus cosine theta times, I don't know why I wrote x. I'm in x mode. That's funny.
I've been using X for theta.
Huh?
I've been using X for
It's
theta.
weird to not write it. It's cosine theta minus 1 times cosine theta minus 1. Because a negative times a negative is a positive. So now could I eliminate things? Yes. Now I'm safe to eliminate. I hope I wrote that right. I feel like I might not have. I think we're good. Did I need to finish CAB, or did y'all know the next process of CAB?
I don't know what that is.
Okay.
What's cab? I don't understand what that is.
Okay. CAB is where it's saying this is your C, this is your A, and this is your B. Oh, I wrote that backwards. A, B, C. My bad. Had a brain fart. It's a quadratic equation. So essentially your cosines are acting as your x values. Remember when you had ax squared plus bx plus c in Algebra 2 or any time in math class? That represented a quadratic formula. Okay? Your a, your b, and your c are the coefficients of them. So the a here is a 1 cosine squared. The b here is a -2. And your c is a 1 without any cosines attached to it. So when you have CAB, you come up with the magical numbers that fill inside the box. So your first term is always what's already there. Your second term is your last one. And then your middle terms are your magical numbers you come up with. So negative cosine theta and negative cosine theta. Okay, so from this, you're now using greatest common factor rules. So if I have, what's the greatest common factor between these two?
Cosine.
Cosine what?
Theta.
Theta. What's the greatest common factor here?
Cosine theta.
Okay, and what's the greatest common factor here?
1.
And what's the greatest common factor here? 1. What would these ones have to be in order for this to be negative and this to be positive?
Negative.
So therefore your factors are, forgot the other one, cosine theta minus 1 times cosine theta minus 1. And that's CAB. Yes?
Yours is negative cosine theta and then negative cosine theta. Why did you turn those two negative?
Here?
Yeah.
The reason why they're negative is because both of these sides have to be true. And if I kept them positive, would I end up with a positive 2 if I added them, and a negative 2 if I added them together? No. But when I make them both negative, because I know a negative times a negative is going to make a positive, and a negative plus a negative will make a negative. So you have to make sure that each side of the cab is true. Again, we just took an algebra skill and boom, and threw it into trigonometry. All right. Okay, so we're going to have to stop right here so you can have time to take your quiz. Okay, let's finish the notes.
Are we solving?
You're simplifying. Okay, this one.